right, well, here we go again. We get to make another one, 4.5 inch. I think it's 19 foot 5 inches long this time, so very similar to the last one I just did. 5.5 inch OD stainless steel liner on there, sled runner style keyways, standard taper, and this one got condemned because of excessive wear in the packing gland area. That apparently happened some time ago, but that's neither here nor there. It has been rejected by the classification society, so we're making a new one. And that's the, it's got what are called Naval style couplings. So this is also another taper, a key fine thread stud there to draw on the coupling. It's almost hard to see the taper on the camera there, but it's the same taper, just shorter as the other end there. So, and there's 3 of those Naval style couplings. So they have a tapered bore. There's the large end of the taper, and then there's the small end of the taper. The stud would project through in there, and then the nut goes on top and draws the whole thing together with a key for good measure. And there's also an intermediate shaft out of that same vessel, so it's got a coupling on each end. So the propeller goes there, coupling here that then couples to there, and then that end goes to the engine, all in a big long line, so to speak. So, and we've got to make some sockets to engage with these nuts. We don't have any in stock, and we don't feel like paying the factory price, so we're going to make some. There's going to be the slug for one of the one socket to fit one size. I guess it's going to be, this is the larger of the 2 nuts that we're got to make a socket for. So there's the slug for that, and there's the smaller of the nuts. So we're fortunate enough to have a piece of hollow seamless mechanical that we can open up and create our socket out of that. So maybe I'll show some of that as I build them. And that's going to be the liner. I got to bore that, heat shrink it on, then turn the OD after I finish building the shaft. And there is the shaft in the lathe. So got it trued up in the chuck there. We're just getting it trued up in the steady rests, and it's just short enough that we can leave the little disc closed to the lunchroom. We don't have to intrude on the lunchroom. And should have made myself one of these a long time ago. Just a piece of key stock with a little piece of flat bar welded on it, and it's the about the appropriate offset that's secured in the tool block. We can then use our magnetic base dial indicator, and it pretty much lines up with center line height. We can always give it a little tweak with the adjusting screw there, but that gets us on there that we can then adjust the cross slide to 0 out. And then when we run our carriage up and down the length of the material, we can predict our tool path and know whether or not we're going to be cutting a cylindrical feature or a conical feature. So there's a lot more to it than that, but just having a little jig, or what would we call that? It's not quite a jig, but a little attachment like that makes life a lot easier. There are times when it's advantageous to attach the indicator in that orientation so you can read it from the far end of the machine, so to speak, but there's a lot of times, especially when you're working near the chuck, when it's much handier to have in that orientation, and then as it gets near the chuck you can just look down and read it rather than to have a peer in from this side. So, and I've been playing with the dial or indicator on the 12 o'clock position on the material, and I'm really learning to love it. And then as I'm tightening up each chuck jaw in succession, the key engages at the top rather than down here. So when you're really trying to give it the old heave ho, I find it a lot easier to do up here, but maybe I'm just getting wimpy in my old age. So anyway, as usual, horrible camera work, boring video. Thanks for watching. I'll try to make something exciting later.